Oh, sorry. I'm sorry. Started by you, let everyone know they are being recorded, okay, and transcribed. So today we'll be looking at partial differential equations. So they say at the end of this learning unit, you should be able to find the first order partial derivative of a function of two or more variable, right? Find the second order partial derivative of functions of two or more variables as well. Now, what do they mean by that? So they mean that so far we have only differentiated a function with one variable. Do you agree? Yes or no?
Yes, ma'am.
And even with parametric equations, you had parametric equation where you had x, okay? Are we choosing a color? Still red.
I'll make it pink this time.
Okay. Ooh, which one is pink here now?
Will it be visible? Will this pink be visible? As long as it's visible, it's fine.
Let's choose my favorite color, one of the blue. Okay. So
blue is okay.
Good. So now remember that with parametric equation, we had x is equals to cos of theta and y is equals to maybe, for example, sine of theta, right? This only had one variable as well. So it's a different, if you were differentiating, it only had one variable. So now in this case, instead of looking at y is equals to f of x, we want to look at y is equals to f of, instead of y, we want to look at z is equals to, now we have f of x and y. So we have two variables now in the same equation. But remember when we're looking at implicit differentiation, right? With implicit differentiation, you had x squared, y plus y squared, z and whatsoever. Now, this is different, meaning that if you're going to differentiate, you don't differentiate the way you used to do in implicit differentiation. You differentiate in such a way that one is kept constant. So one changes into a number. Whether it's a 1, it's a 2, it's an a, or whatever you call it, you keep the other one constant. And we know that the derivative of a constant is equals to 0. So at some point, if we're going to differentiate z, okay, let me not explain that part, but we just have to keep the other one constant. So they are saying that now we look at differentiating functions of two or more variable, right? For example, consider a volume V of a cylinder. We know that the volume of a cylinder is equal to pi r squared h, where r is the radius and h is the height. Thus, the volume depends on two quantities. Do you see that? So the volume depends on two quantities. In this case, you can call them x, y, but we know the two quantities or the two values are r and h. If we keep h constant and we change r, the radius, the rate of change of volume is then denoted by this. So meaning that the rate of change of volume as R changes is given by what? Is given by dV over dr, keeping H constant. So meaning we are making H constant, basically. Does it make sense up to this point, guys?
Yes, it does, ma'am.
Yes, it does.
Okay. So now, since we're keeping one variable constant and we are differentiating the other, we're no longer going to use the dy dx or dv over dx. We use what we call the partial derivative, which is this Kelly derivative here. Are we all together?
Yes, ma'am.
Yes,
There we
ma'am.
go. So hence, if let's say hence they're saying that now we're no longer going to use this. We're going to use this one over here. That is, you are partially differentiating v with respect to x while keeping h constant. So they say, notice the new notation, the curly d's, which is something like that. I used to distinguish between partial derivative and ordinary derivative. Partial derivative is this, and ordinary derivative, it's the d. It is read as the partial derivative of v with respect to x. So meaning that if you find this curly v over curly r, we differentiate the given expression taking h as a constant. So as you see here, meaning that h is constant, we just differentiate what? We just differentiate the r. So we can also keep r constant and differentiate with respect to x. I mean, with respect to h. So meaning this is how you do the notation. Now they say that instead of the curly v over the curly r, the partial derivative of v with respect to r can also be written as v underscore r. Is v subscript r? In addition, the partial derivative of v with respect to h can also be written as v subscript h. Are we all together there? So don't be confused in the exam when I ask you find vh. So now, in most cases, if you're looking at a variable with a function of two variables, it means that it's a function in a 3-dimension. Are all together? So in the, what's this? It will be in an x, y, and z. So if you're looking at a function of 4 variable, then it's a function in 4-dimension. Maybe it can be an r is equals to the function of x, y, z. So you can go and read that by your own. Are we all together there, guys?
Yes, ma'am.
Yes.
Thank you.
Yes.
So now here's an example. Let's take a screenshot. Let's say example 1. In example 1, they want you to find the derivative. But you don't call it the derivative because what they're looking for is a Kelly derivative, meaning that you are looking for the Kelly D. When we said Kelly D, then this is a partial derivative with respect to x and also a partial derivative with respect to y. Meaning that you're, in this case, if you want the Kelly z over Kelly x, you keep y as a constant. So, or you make y as a constant. So let's see, going back to blue. So we have z is equals to 3x squared plus 5xy minus y to the power of 3. Are we all together there? So now they want us to find the partial z. Guys, make sure in the exam you write partials because some of you are still using d for partial derivatives. So what will be the answer here? Let's try. Based on the information given.
6x
6x
Yes.
plus 5y.
plus 5y
Mhm.
minus y3.
Y3 is a constant, so keep it there.
So y3 is a constant, so we keep it there.
No, if y3 is
No.
a constant, shouldn't it be 0?
Thank you. The derivative of a constant is what? Is 0. So this is the answer. Does it make sense, guys?
Yes, ma'am.
Yes, ma'am. Remind me again, what happened to your x when you derived 5xy?
You differentiated x. So remember when you differentiate, when you have 5x, when you differentiate, you only get 5. So that's what happened to the what thingy? What happened to the x? Because you differentiated with respect to x.
So then why did we keep the y there?
Because it's a constant. So if this y was a 2, let's put here 2. So what was it going to be?
Then just 10. Okay.
There we go. There we go. So then it was just going to be times 2, which is 10. In this case, y is a what? Is a constant. We don't know the constant. Remember in maths, if we don't know the constant, if it's an arbitrary conference, hey, if it's an arbitrary constant, meaning it's if any given constant, you give it a variable, isn't it? You give it a y, you give it an a, you give it a whatever. So that's why we're keeping the y, because it's a constant. But if y is a constant and this was 2 and this was 2, this one, because it doesn't have an x, it will just disappear. Not really disappear, but you know that the derivative of constant is what? The derivative of a constant is zilch. Is it making sense now?
Yes, ma'am.
Yes, ma'am.
Thank you. Let's
Yeah,
try the
yeah,
next
yeah.
one. So the partial z over partial y. Make sure that when you do partial derivative in the exam, you are sober. Because they will give you a problem. I know myself. Okay, I don't drink, but I know myself. When I'm tired, I can't do partial derivatives. Even the easy ones like this one. So let's look at partial z over partial y. So the partial, it says the partial derivative of z, we are differentiating z with respect to y, leaving x constant. So that is the partial derivative of z with respect to y. What is the answer?
5x minus 2y squared.
5x
3y
minus
3y squared.
3y squared. Did we all get that?
Yep.
Yes, ma'am.
Yes,
Hmm.
ma'am.
Mm-hmm. Mm-hmm.
So that is partial derivative. And it's in your assignment, I know. I put it there. Okay, so we'll skip this one. We'll come back if we have time. And that's how you do partial derivatives. And then we come to second order partial derivatives. Now they're saying that, remember we did our first, so in this case, we'll only do the first order and the second order. We won't go further like how we did with ordinary differential equations. So let's look at our second order partial differentiation. So they say the function, remember the function, has two first order partial derivatives. Are you hearing that? Two. Where they? Right? So if you go in the exam and say find all partial derivatives, you're going to find all first partial derivatives and find all second partial derivatives. How many first order partial derivatives does a function with two variables has?
2.
Guys, 2. So how many first order partial derivative with of a function with 3 variables will have?
To have 3.
Well done. So since the partial derivative of x, the partial derivative of z with respect to x is a function of x as well as y, then what they're saying is, since you can see, look at this, in the partial derivative of z with respect to x, I still have a y. So meaning that I can go and find the second order partial derivative of z with respect to x and also with respect to y. So meaning here I'll have two second order derivative here. Even here with respect to x and or with respect to y, it means I also have two order derivative here. So let's go and see. So they say that, okay, the rate of change of this partial derivative with respect to x or y can be determined by a second order partial derivative. So meaning that this is that. That's how you write the second order partial derivative. Are we all together up to that point? Can I move on?
Yes, ma'am.
All right.
Yes, ma'am.
So how do you do this thing called second order partial derivative? Meaning that, remember, you had the first partial derivative, which is this one over here. So if you're going to get partial squared z, which is the second order derivative, partial derivative, you take the partial derivative of the partial derivative of z with respect to x, then partial differentiated with respect to x. Makes sense?
Yes.
Yes, ma'am.
I need 3 yeses.
Yes, ma'am.
Yes, ma'am.
So
Yes,
same
ma'am.
applies. If you have the partial derivative of z, the second order partial derivative with respect to y, so you take the partial derivative of the partial derivative of z with respect to y, take it with respect to y as well. That's that one. But now we said that, remember, the first order have 2 of them, so meaning there must be another one. Here's another one. Also, the rate of change of z with respect to y, meaning that now, in this case, you're keeping x constant. can be determined by the second order partial derivative, where, look at this, let me enlarge so that I write here and I don't go anywhere else. Look at this. Do you see the difference between this and this? Ladies and gentlemen, look at those two second order partial derivatives. Do you see the difference?
Yes, ma'am.
Now, in mathematics, normally, when we read, whether it's functions or whatever, we read from left to right. Now, in partial derivative, we read from right to left in the denominator. So here we have the second order partial derivative of z, partial y, partial x. What does this mean? It means that we first start with this one. You partial z, you find the partial derivative of z with respect to x first. After, you then differentiate partially with respect to y. So this is then partial. What am I saying? The partial derivative of z with respect to x. Do you see that? You first differentiate with z with respect to x, the answer, then you come and differentiate it with respect to y, keeping x constant. Are we all together?
Yes, ma'am.
Yes, ma'am.
So you go in the opposite now instead of normally going from left to right.
Yes. So with partial derivative, you in the denominator, you read from right to left.
Okay.
Yes. There's something, the thing is, I don't want to tell you something because it might be an answer to something that I don't want to give you the answer for. You will see what will happen in future. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yep.
So I was expecting someone to ask that question. I know when I was doing calculus, someone asked the question. I think it was in applied maths, this one, not in calculus, but someone did ask the question. Like, oh, and maybe the question is also in the. Okay, I come back. So now let's look at this one. Where's the page? Let me open it in the textbook. It's page 14. Okay, look at this. How many all, when I say all partial derivative, how many are you looking at? Looking at 1, 2, 3, 4, 5, 6. Do you see that, guys?
Yes, ma'am.
So let's start
Yes, ma'am.
with this one here. May I please have the answer? So the partial derivative of z with respect to x is equals to what? Let's see. Don't look at your study guide. Close your study guide. I'll be looking at the answer in the study guide.
It's 6x plus
6x
4 plus 4x
plus 4x
minus 3.
Isn't it 4xy?
Isn't it 4xy? There's a question. Question. Isn't it 4xy?
4xy. Yes, it's 4xy.
No.
Sorry about that.
Okay, there's a
There's
no
a
now.
constant, right?
3y squared.
Yes. Now, okay, guys, I'm also confused. Is there 4xy or there's no 4xy?
There's a 4xy because
There
the
is a
y is kept
4xy.
constant.
Yeah,
Made it
yeah,
with
there's 4xy, definitely. Yeah,
Is there
there's
someone
4x.
who's is there someone who's confused at the moment?
I don't think so. I'm clear.
If there's someone who's confused, maybe we can make it in a simple way
Yes, I'm confused, ma'am.
on how to differentiate. Okay, look at this. This is how I'll say you do it, ne? You understand when they say partial z over partial x, isn't it? You do understand, right? So now they are telling you, they want you to differentiate with respect to what? With respect to, they want you to differentiate, ignore all the y's for now. You keep them as a constant. And then differentiate the x's only. So you can do this and say, okay, fine. Here's my y here is a constant. Here's my y here is a constant. Here's my y here is a constant. Are we all together? So
Yes, ma'am.
if you highlight
Yes,
those ones
ma'am.
now, let's highlight those ones for now. Don't care. Don't look at that. Do you see that you are remaining with? So if you highlight those ones, plus 2x squared, put a dash here. I put a dot here to represent that the highlighted. Minus 3x dot, right? Plus 4 dot. Do you see that? Are we all together there?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes or no? So now the derivative
ma'am.
of 3x squared. So the derivative of 3x squared is 6x. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now
Yes,
plus
yes.
the derivative of 2x squared is what?
It's 4x.
4x.
It's 4x.
X. Do you see that?
Yes.
Come put the dot. Right? Now here, the derivative of 3 minus, okay, so the derivative of minus 3x, what is it?
It's
Minus
minus 3.
Minus
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 3.
three.
Come put, yes, come put
Dot.
the dot. Are we all together?
Yes.
Yeah.
You see here, there's no x here.
Hmm.
So x, you know when 1 is the same as x to the power of 0, you know that, right? So meaning since there's no x here, there's a constant, which is a 1. Do we agree?
Yeah.
Yes, we
Yeah.
agree.
Yeah. Yeah. Yeah.
So what is the derivative
ma'am.
of 1?
0.
0.
Zero.
Right? Or even not even a 1. This 4 here. What is the derivative of that 4?
0.
It's a
Zero.
0.
0, right? So then you go and say plus 0 times that dot. Do you see that? Now, when
Yes.
you return your dots, you know your dots are represented by y. So then this is equals to 6x plus 4xy minus 3y plus 0 times y. And we know 0 times y is what? Is 0. So this is 6x plus 4xy minus 3y. But wait, 3y has a squared. Sorry. So it's 2
cube.
dots. So meaning that this will be what? Squared. Y squared. Are we all together?
Yeah.
Yes, ma'am.
So meaning that you need to take it in a simple manner until you get used to it. So for now, let's say, okay, fine. If it's y squared, then it will be dot squared. Let's do that. If it's x squared, then it will be dot squared. So that we then get to a point where we get used to the fact that if we are partial differentiating, one needs to be kept constant. Does it make sense now? For those who are
Yes,
confused.
it does, ma'am.
Yeah, it makes
Yes,
sense,
ma'am.
ma'am.
Okay, so now remember we have partial z and partial y. So which one are we dotting now? Let's go back. Which one are we dotting now?
The x.
The
X
x, right?
X.
So meaning that here we will have, okay, let's erase. Guys, remember you are paying school fees or your bursaries are paying school fees. So you can't go without understanding. So you have, it means that you have z is equals to, we are dotting the x, right? So we have 3 dot squared plus, what do we have here? We have 2 dot squared
Good.
plus y times
Y.
multiplied by y, right? Minus 3 dot y squared plus 4y to the power of 3. Are we all together there?
Ma'am, what happened to your x?
Okay.
Oh, yeah, never mind. No, I see. Never mind.
Dot.
Okay, so now remember, because we are looking at the partial derivative of y, there's no y here. Do we all agree?
Yes, it's a constant.
It's a constant. So we are differentiating. What is the derivative of a constant with respect to y?
0.
0.
So then this will be 0 times dot squared plus what's this?
2.
Do you
Dot
see that? You
squared.
have 2y. So then that's 2 times dot squared. Don't write it like this in the exam. We're just getting used to doing partial derivatives here. So here, what do we have?
Minus 6 y times dot.
Is
Yes.
there someone who's still confused,
Derivative
guys?
of y is 1.
Is there someone still confused? Or we are okay? Can I continue?
You may.
Where did the dot come from? I get the minus 6y because you derived it, but the dot?
Remember, we are replacing the x
Sorry,
because we are
minus,
partial
minus
differentiating.
6. Minus 6 isn't x the constant? So where do you get the 3 to multiply with? Because if x is a constant and in front of x is 3, isn't that supposed
Yeah,
to be
but
0?
you can write it like this: minus 3y squared times dot, like this.
Okay. I thought
So
it was
then you
an-
can,
okay.
yes.
Okay.
So then you can differentiate this. When you differentiate this, becomes minus 6y times dot. That dot. Remember, we replaced x by dot because we want to partial differentiate with respect to y only for now.
Okay.
Okay, I think I was getting confused by this 3. I thought it was just, I took it as 3x, therefore that would be the constant without any 3 in front of y. So when you're
The
saying...
reason why we put
six-
dots is because we don't want to see x so that we don't get confused. Do you see that?
Okay.
So in this case, we only have 3 in the first one. In the
Okay.
second, we have 2y. In the third one, we have negative 3y squared. And in the fourth one, we have 4y to the power of 3. Does it make sense? Or some people are still confused, guys.
Making sense.
Okay.
It's making sense. Let's see this to the end.
Okay. 3x is a constant, right? It's dot, okay?
Yes.
Okay, it's 3 dot squared. The next one
Yes.
is 2 dot squared y. Okay,
Yes.
and then the third one is 3 dot y squared.
Yes.
Right? And then the last one is 4y to the power 3. Okay. Then when you do the derivatives, why do you still include this 3 in front of y? I thought if you are going to do derivatives of 3 minus 3x, it was going to just be 0, and then we'll only be left with y. That is where I'm a bit confused.
Minus 3x here.
Yeah, but then I think you are saying...
But there's no y here.
Okay.
Do you see that?
The third one.
The third one becomes, it becomes minus 3y squared. So differentiate that. Forget about the dot. Differentiate this only.
Okay.
Do you see that?
6. Okay, minus 6y. Yeah.
Do you see that? The reason why I'm putting dots is because I want everyone to see that you are covering out. You are ignoring, for now, you are ignoring x and you're only focusing on y. That's why I'm putting dots there.
Okay.
Does it make sense? Is there
I'm
someone
basically-
confused?
So we're basically doing the opposite of what we did now. We derived with respect to x, now we're deriving with respect to y.
No, I understand
Yes.
that. I understand that perfectly. But I thought when you do the derivative, since the 3 is in front of x, both were just going to be 0 and we'll be left with y. So when you say 3 minus 3y squared,
If you were to differentiate this,
okay, minus, no, instead of minus, okay.
if you were to differentiate 3x y squared,
Yeah.
how were you going to differentiate that? Isn't that you were going to say, okay, fine, it's 3 times x times 2y, then it becomes 6xy. Because you're differentiating y, isn't it?
Okay, I understand this one here, but I think I thought maybe since this was going to be a constant, the x was going to be a constant, I had already removed the x instead of going down and simplifying first and get to the minus 6xy. So basically, if I was
You're not
to
taking
solve,
out the x,
okay,
guys.
okay,
Listen to this.
you're not okay.
You're not taking out the x. I want us to clarify because I've noticed it's a lot of marks in the assignment. You're not
Okay.
taking out x. X is a constant. So let's do this. Let's make x 2 instead of a constant. Let's choose a number then. Because I see there are people who are still confused. And I don't want you to get confused.
Ma'am, can I
Yes?
maybe make a suggestion?
Yes, please.
Can we leave out everything and just keep the x's there? And then when we derive, we just derive the constant. And then so if we're deriving the 3 in front of the 3x squared, and we're doing it partial derivative to y, then it will be 0 times the x to the square, right? Still 0.
Do you see that?
Yeah, so can we just leave the x's there and then derive via y?
Okay. So let's try what she just said. Do you understand?
Okay.
In the exam, you'll write it because now as the more you practice, you get used to differentiating with respect to what? You won't be introducing dots or whatsoever, right? So we are saying, okay, fine, we want to find the partial derivative. The partial derivative of what? The partial derivative of z with respect to x. It means that this is what you say. We're going to differentiate anything that has an x, guys.
Yeah.
And everything, as she said, let's leave it like that. Everything, let's leave it like that. Are we all together?
Yeah.
Because everything is a constant. Even if we can replace it with a dot or with an a, everything is a constant. Here, everything is we leave, okay? That's a very good suggestion. We leave everything the way it is and differentiate the x. Here, what are we going to leave? Let's start here. What are we leaving here? The way it is.
The 3.
The 3, right? Then let's differentiate do we have an x here?
Yes.
Yeah.
So what is the derivative of x squared then?
2x.
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 So that's 2x. Plus,
Okay.
we are focusing on the x's, right?
Yeah.
What is there that we need to leave the way it is?
2y.
2y. Well done.
Yeah, 2y.
So that's the 2y. Then we're differentiating this x. So what is the derivative? There we go.
Yeah.
That's 2x.
2x.
That's well done. Minus, what are we leaving here the way it is?
3y
3y squared.
3y squared. What are we differentiating? This x.
X, yeah, only x.
So what is the derivative of x?
1. Okay, yeah, this makes sense. This is
now, what are we leaving? Do we agree that 4y to the power of 3 can be written as 4y to the power of 3 times x to the power of 0?
Yes.
Do we agree?
Yes, yeah.
Yes.
Okay, so meaning, what are we leaving here?
4y cubed.
Plus 4y cubed. What is x to the power of 0?
1.
1.
What is the derivative of 1?
0.
0.
0.
Times 0. So then this becomes 6x plus 4xy minus 3y squared plus 0. This becomes 6x plus 4xy minus 3y squared. Makes sense now.
Very much so.
Mm-hmm.
Thank you very much for the suggestion.
Sorry, ma'am, but I think previously you had 6y somewhere, and this is where I was confused. I think so.
That was the
Yeah.
next partial derivative. That was derivative of z by derivative of y.
Okay.
So let's
That was
see
the
that
confusion, I think. Yeah.
Remember, guys, we are paying here. We are paying our fees. So we need to understand. We need to find ways. As I said, it's a discussion class. We need to find ways. And the suggestion was very perfect. So let's do that. Come on. Now we partially differentiating with respect to y. What are we ignoring? What are we keeping the same? Because it's a constant. Keep it a constant. Let it not move. When you keep something constant, it's not moving. You're not differentiating. Well done. So then the partial, why am I saying well done to myself? The partial derivative of z. The joys of doing math. So the partial derivative of z with respect to y. What are we keeping constant? What are we keeping? Keep
everything but y.
Yes, we keep the way. Let's no longer talk about keeping constant. We keep the way. What are we keeping the way? We keep everything the way. Okay. Now, is there a y here, guys?
No.
No.
Well, there is.
No
It's y to the
Yes,
0.
y to the power of 0, yeah.
Well done. So we keep 3x squared times y to the power of 0, and we know y to the power of 0 is what?
1.
1. The derivative of that is what?
0.
0. Now let's change how we were thinking. Because we are partial differentiating with respect to y, anything that doesn't have a y, it's 0.
Yeah, okay.
Makes sense, because we
Yeah.
saw how the 0 comes in. So meaning that there's no y here, so that is 0. Right? Plus, what are we keeping the way it is? Keep everything the way it is. What are we keeping?
2x squared.
2x squared. What are we differentiating? Y.
Y.
So the derivative
Y.
of y is what?
1.
1.
Y.
2. Yeah.
Minus. What are we keeping the way it is here?
3x.
3x.
So it's 3x. Then the derivative of this is what?
2y.
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 Plus.
Y.
Here. What is the derivative of that?
12y squared.
12y squared.
So this is equals to 2x squared minus 6xy plus 12y squared. Are we now in the same picture? Let me see. Is it right? 2x squared minus, yes, well done. Now are we now together now? Are we?
Yes.
Yeah, makes sense.
Yeah.
Good. Now that it makes senses in the upstairs of our minds, so let's go to the next one. So the next one says the partial derivative of the second order partial derivative of z with respect to x. What does it mean?
It means that we do the partial derivative of the partial derivative of z by dx.
Partial derivative of z with respect to x, right?
Yeah.
Then we go and partial differentiate it again with respect to x. So meaning that, do we have the partial derivative with respect to x? Let's see. Yes, we do. We did calculate it. So the partial derivative of z with respect to x, we found that it was 6x plus 4xy minus 3y squared. That's what we found, ne? Let me see, 6x plus 4x plus y. Now they want you to find the partial derivative. Now the second order partial derivative with respect to x. So meaning they want you to, the partial z squared over x squared. This is, you take the partial derivative with respect to x of the partial derivative of z. Like this, with respect to x. So this is equals to the partial derivative of this expression over here, which is 6x plus 4xy minus 3y squared. Are we all together?
Yes, ma'am.
Yes, ma'am.
Now,
Yes, ma'am.
we are partial differentiating with respect to x. Do you see that?
Yes, ma'am.
So what? Let's
Yes.
apply what we have learned. What is the first one now?
6.
6.
6. The second one, which one are we keeping the way it is?
4y.
Because there's a y.
Four.
Then differentiate x, we get what?
1.
1.
minus.
0.
0.
0.
You see that? Now you are
Yeah.
getting the hang of it. So then this is 6 plus 4y. So now they want the second one. Where's the second one? This one. So meaning that we need to go and find the partial derivative with respect to y. We know that one. So the partial derivative of z with respect to y is equals to what? Is equals to, please mute, 2x squared. Someone is typing or doing what? Mute. Thank you. 6xy plus 12y squared. So they want us to find the second order partial derivative with respect to y. So meaning that they want us to find z over partial, y squared. And how do we find that? We say partial y of the partial z partial y. So meaning that this is partial of partial y, then that's 2x squared minus 6xy plus 12x, y squared. So this is equals to what? Now we got the hang of it. Let's do it.
Minus
this is equals to what?
6y.
The first one.
Oh,
Does
0.
they have a y?
0.
Thank you.
0.
Then
Minus 6y.
Minus
Minus
6.
6y.
Oh, sorry. Sorry, it's minus 6, not minus 6y.
Yeah, minus 6.
why is it minus 6 now, guys?
Because there's no square on the y.
And
It's
so that's what?
minus 6x.
Minus 6x.
Oh, yeah, yeah.
Thank you. Minus 6x. We're putting the x the way it is constant, and we are partial y.
Yes.
There we go. Plus
24y.
24y.
done. So therefore, the partial z partial y squared is equals to minus 6x plus 24y. Exactly what they wrote in the study guide. Are we getting the hang of it?
Yep.
I want you to-
Yes, ma'am.
Yeah. Definitely.
Where are the ladies, the other ladies? Guys, ladies,
Yeah.
are you here?
Yes, ma'am.
Yes,
we
ma'am.
are here. You are understanding the work.
Yes,
Yes,
ma'am.
ma'am.
Yes.
Okay, no problem. Thank you. Well, I see today it's male dominant. Like there's only one lady, and then all the guys. I'm not saying equal. I'm just saying, Okay. The next one, what does it want us to do? You tell me this one. What does it want us to do?
You're supposed to take the partial derivative of y of the partial derivative of z by x.
So which one is the first partial derivative then?
It's partial
You need to take the
derivative
one of x.
z with respect to x.
There we go. So the first, remember, I said we read from this side
Right
to that side.
left.
So then we need the partial derivative of z with respect to x. That's the first thing we need. And we found that that one was 6x plus 4xy minus 3y squared. Right? So then, because they want the partial, then it means you need to go and take the partial derivative with respect to y now. So then this is partial, the second order partial derivative with respect to x and with respect to y. So this is the partial of y. 6x plus 4xy minus 3y squared. I'm not going to solve that. Can I have different voices? Let's hear. Because people say they understand. Let's hear. Hello.
It's going to be 0.
0
Ah,
plus
I had those
They want the
voices.
plus
same
4x
voices.
minus 6y.
No. I want different voices. I know there's over 30 people in this. There's over 4 people. Can I have different voices, guys? Otherwise, we stop the class.
Yo.
0. So I had a 0. Yes, 0. 0 plus
4y
4x minus 6y.
What?
Minus 6y.
plus
Is she
4
right?
0.
Yes, ma'am.
Yeah, she is.
I want also different voices, guys, because some people are sitting with answers there. They don't want to participate. Let's participate.
0.
Don't be shy. We don't bite.
Okay, mute.
What?
Are we all together in this program now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Danko. And I need another different voice. I don't know what my laptop is doing now. It's doing shenanigans. Shenanigans. Okay. Yeah. It's doing what it's not supposed to do. Okay, let me go to another page. I'm glad you guys are seeing the picture. You can see clearly now. The rain is gone. Okay, let's see. Now they want this one. Partials. Yeah, that one. They want that one. So which one do we need? Which is the first order partial derivative we need for this one?
The one
Partial z
Respect to
by
y.
partial y.
Okay, let me look for the partial z with respect to
Z
y.
over dy.
Yes, partial z dy. I wanted a different voice again. 2x squared minus 6xy. Now, someone should not ask me where did we get this. We calculated it. Is this one? We did that. Okay, let's do this. So meaning that you go partial x, partial y. So then you want the partial of a partial x of this one over here. So that's 2x squared minus 6xy plus 12y squared. My different voice, can you speak?
Okay, ma'am. So we have 4x
Yes.
minus 6y
Yes.
plus 0.
Plus 0. Can I breathe? You discuss. I go to drink some water. Yeah, let's say there's just water involved. So yeah, discuss for a few minutes and then I come back. If you see what I see, then it's fine. If you don't see what I see, then it's also fine. So you can discuss. What do you see and what don't you see? That's a question.
Plus-
What do you see and what don't you see?
The last term
The
has
last
not
two are the
yet been
same.
differentiated.
They have the same answer as well.
Last term is 24y plus 24y.
No, because we're doing it via x. We differentiate it via x, so that's a constant. X to
Yeah.
the
So it
zero.
must be 6.
No, it's correct. The
second
answer
term.
is
Zero.
correct.
Is
Second
0
term.
because
Correct
it's not.
as it is.
The two
Yeah, there's
last questions
there's no
that we did
x.
have the same value.
Yeah, but okay, but guys, the previous one where there's xy, you still left x, if I'm not mistaken. Was it?
No,
What was the answer there?
the answer was exactly the same. It was 4x minus 6y.
With the previous one, the answer is the same. So which means that the partial derivative with respect to x and also with respect to y are equal with each other.
But isn't that the same as us doing the compound? When we put one figure into another, then we got the value of
we're
x.
deriving in terms of x here. Okay, okay, 4x. Okay. And
So
then
when we put the inverse
it's
into
6
a
and then
function.
this remains.
Yes, yeah.
Okay.
I think it concludes with the last two partial derivatives to say that both of them are equal.
Did you see what I saw? Or you didn't see what I saw? Seesaw. Okay, what did you conclude?
The last two that we did had exactly the same answer.
All
But
right.
but we
But-
put the function of the partial derivative back into the other function.
Why did you do that?
No, when we were working it out. So when we did partial derivative of y of the partial derivative of z with respect to x.
Okay, someone I have to remove from the meeting. Muchacho, you're making noise.
Who?
I think Muchacho, is it you? The one who's going show. Please tell me who's doing the show thingy. We remove.
Mohato, are you trying to say Mahato? Or?
Machato, oh sorry, Machato. Is it you
Yeah,
doing
it's
the
me. What hush are you talking about? I don't know what you're talking about.
There was some noise.
Am I making? Okay, sorry. I'll just mute my mic then.
Yes, when you after talking, just mute. Okay, so can we go to something? Okay, I'm stopping the recording, ne?
Okay.
Yeah. I'm assuming there's no question.
Wait, did we come to an answer? What did you notice?